Since I'm redesigning this crossover, I want to do an extra experiment. Mondorf capacitors and superior Z cap, and one with the cheapest components ever. This switcheroo, which you can connect the speakers and blindly tell the difference. I'm quite curious. What's up guys, it's Marius from Audio Judgment, and today we're going to upgrade that thing. Maybe you already built it or you plan in building it, but now we're gonna upgrade it and try to relax a bit, because don't think that this is like a night and day upgrade. Let's call it incremental. So there are a few things that I don't like about the speaker. Some we can fix, some we cannot. Some we can mend a bit, but let me show you what I mean. So the first thing I want to talk about this speaker is the panel sizes. So normally when you build a floor standing speaker, ideally you would want 22mm panels on the sides and on the back, and on the front you want 35mm. Now this has 18mm all around. So basically if you use how it was meant to be and just double the front panel, so you keep all the sizes and just use two panels stacked, the internal dimensions are the same and you just need two front panels. And this issue is solved. Now obviously I can't do that right now because the box is already made and finished, but I don't think this is a big issue because this has four braces, window braces, one over here, one over here, one over here, and one over here. So I doubt there will be any problems with panel resonances. The issue I have with this is that the box is slightly lightweight and top heavy because it has the speakers on top. So if you try to push it from the top, it easily tips over. So I don't like that thing. We can fix this using this stuff. So basically this is damping material used in a car, but obviously you can use it for the inside of the box as well. So I'm going to strengthen the box using this material and focus on this area, maybe put 2 layers to make it a bit bottom heavy. Now, the next problem with the speaker, or let's not call it a problem, the next upgrade I want to make to this speaker is the damping material. So basically now the bottom part is full of stuffing, and I want to try to use this stuff and try to line the walls and maybe use a combination of stuffing and lining. Now the problem in a floor standing speaker is that the odds are great you are going to have problems with the standing waves. And this is no exception, there is one present. And to fix it, you basically add sound absorbent material and the standing wave will be absorbed. Now, if you add more and more sound damping material, you will reduce the effect of the standing wave, but the problem is that the output of the port will get reduced as well. So in an extreme situation, let's say you fill the box to the brim with the sound absorbent material, you basically have a slightly leaky sealed box, even though it has a bass reflex port in it. So there is a balance to be made over there. So right now I'm trying to add some lining, some wall lining, and maybe a combination with the stuffing in the bottom chamber. And hopefully we will reduce the standing wave without affecting the bass response, or maybe even improve it. Now the next thing I want to improve is the off-axis response. And basically I kind of failed on that part. Now to fix that you have some options. reduce the distance from the tweeter to the bass driver. Obviously we cannot do that because the box is already finished. But we will redesign the crossover. And in the crossover you can set the crossover point lower. Now I tried to do that, but the problem is if I go too low, I'm afraid the tweeter won't be happy with that. So some choose to set the crossover point very low. It can work, but you have to be really careful with the volume. And I don't trust people with the volume knob. So basically what I did, I redesigned the crossover. You can see a mock-up over there on the floor. And the advantages are as follows. I managed to remove the large capacitor on the tweeter side, the 22 microfarad one, which is quite expensive. And while the off-axis response maybe is slightly better, but I think it's kind of the same. It wasn't that bad to begin with. The advantage is that the on-axis response is better. And I'm going to show you at the end of the video what I'm talking about. Now, besides the new crossover design, I want to do an extra experiment as well. So you can see in the back that box is already done with damping and stuff, and you can see some wires coming out of the bass reflex port. This is because I want to do some future testing. So let me give you a glimpse to look at this. This is a 8.2 microfarad capacitor. That's cool. In this bag, I also have some capacitors. Some of them are 8.2 as well. This one costs like 40 bucks and that one's like 50 cents. So since I'm redesigning this crossover, I want to do an extra experiment in the next video, not this one, where I compare top-notch crossover with high-end components. Look at this inductor. Okay. And one with the cheapest components ever. But I'm going to try to match them value-wise. I'm going to actually measure them. And see if there's any difference. I'm quite curious about this. So next I'm going to tear up this speaker. I'm going to show you where exactly I put the sound dampening material and sound absorbent material and how much stuffing is in the bottom chamber. Then we're going to take a look at the crossover design and how the frequency response looks and compare it to the old speaker. So let's go.
Magic pills. I don't know what's happening. Someone gave me some magic pills.
So the first thing I want to talk about is the standing wave and the effects that the damping has on it. So let me take the port response shows it the best. So this is the standing wave. As you can see, a large peak. The thing you want to achieve is that you want to make the largest difference between this level and this level, because the port has so if the port is very loud compared to the standing wave will not be heard. This is the main idea. So this one has 100 decibels and this one has 92, so 8 decibels difference. Now if we look in the second iteration, the port, where's the port? The port. So we can see that the level is much lower. So in this case we have 86, maybe 87 decibels, so 13 decibels difference. So much better in this case. And if we look at the bass response, is basically the same. So we reduced the output of the standing wave while maintaining the bass response. And now if let's take a look at the full response. So this is the old one. As you can see, it's a bit choppy, and this is a mistake on my end, because if we take a look at the response I published initially, we can see that the response is super flat. This is a mistake on my part, because if we take a look at the scale, we can see that the graph has like 120 decibels on the vertical scale, and that is very misleading. It's not something that I did intentionally, it was out of ignorance. So if we use a normal scale, like a 50 or 60 decibel scale, we can see all the imperfections. So as you can see right here, the response is not that flat. It has his peaks and valleys. And if we compare it to the second iteration, which is this one, we can see that the response is much flatter. There is this peak over here, which I don't know what exactly is. It's something to do with the box response. Nothing that I could do. Can't really fix this in the crossover design because you need a huge inductor, so I left it as is. So improve the frequency response on axis. If we take a look at the off axis response, this is 0 degrees without the near field measurement, so just the far field response. And if we take a look to the vertical, 10 centimeters up, this one is 15 down, so slight dip over here, but basically the same as the on axis. 15 degrees right, 15 degrees left, basically the same. As we go to the 30 degrees, slightly worse. And on the other side, because this is not a symmetrical speaker, again we're losing the top octave as expected. And on the 45 degrees, which is this one, the response starts to get worse, but this one I think is look quite good for 45 degrees. On the other side, it looks kind of wonky. But then again, the off-axis response looks pretty good to me. And now if we look at the crossover design, on the left we have the old design, on the right we have the new. And the main idea is that I excluded the 22 microfarad capacitor, and we have second order filters on both the tweeter and the mid-bass drivers. You can see two capacitors in parallel over here, because you're not going to find the 9.7, 9.8 microfarad capacitor, so you need to combine different values. On the bass side, you can see one 11.2 Again, you're not going to find that the value, and I combined two 5.6 microfarad capacitors. The inductor is slightly smaller to improve that linear response, and that's basically it. So, simpler crossover design. So if you already made this speaker and you want to make a slight upgrade, you can follow the instructions. I'm going to post a link to an article on my website where I give you full instructions on how to put the damping material in with the crossover design. But not only that, we're not done with this project. Like I said, I want to make very high-end crossover. So we have the crossover design, but the parts I'm going to choose will be very high-end. And also I'm going to make a crossover with very cheap components. So I have them over here. So this is Mondorf capacitors and superior Z caps. We have foil inductors. And on the other side we have iron core, which are the cheapest, and electrolytic capacitors. And I got the problem with electrolytic capacitors is that they say there are some value, but they are not, because they have a high tolerance level. So I bought many of them. I'm going to measure. So I'm making sure that I have the exact value. So the value is not a variable, only the quality and how they are made. So that's going to be interesting. And I'm going to do a blind test. I have this this switcheroo, which you can connect the speakers and blindly tell the difference. I'm quite curious. So if you're curious as well, don't forget to subscribe to the channel, and I'll see you next time. Peace!